What's up, YouTube? This is my C++ Minecraft clone. Like every stream, we'll do a summary for people that are starting for the first time this series and have no idea what's happening. Then with chat, we will decide what we're going to do during this stream. And at the end of the stream, we'll do a summary what happened during this stream, which will be in about 3 hours, maybe 4 hours if we forget to look at the time, like yesterday. So we'll start with the simple summary chat, and also there is a surprise feature that I've added to the stream. We'll see if it works. Hopefully it works. So let's start with the summary chat, because most people are new to this series and have no idea what's happening. So this is my Minecraft clone. It's made in C++ and Raylib. We've worked on it for 2 months maybe. For 2 months or like maybe 3 months already. It's close to 3 months. On 17th of August, it will be 3 months, I think. So we're close to 3 months, chat. So we have this 360-degree view of the entire screen. It's a panoramic view. We made this in one of the previous streams where we captured 6 screenshots in-game. We created this menu. We have sounds when we click the buttons. And we start by default in creative mode, flying around. We start in creative mode. We have a player. We have collision that is working all right. We have this right hand that animates. We have a sky that is a single texture and it's not endless. We haven't made it endless. We have this creative mode inventory, and my favorite feature is that the inventory has this scroll bar, chat. This is my favorite feature. It has a scroll bar, and we can pick whatever item we want. The items have animations like this. Items have animations, texture animations. We have TNT, and we added sound to the TNT. We added sound to the TNT on explosion, and when they prepare as well. And they use random sounds, chat. They use random sounds. My mom calls me to come eating. Well, you better listen to mom, because when they're angry, they're scary. So go and eat. What are you gonna do when you're finished? There isn't a finish line. We have water as well. Look at how water spreads. It spreads and it's infinite. As long as it can go down, it goes down, chat. Also, water prioritizes. Bro, this water spreads so much. Water prioritizes. Like here, if we have a hole here, it will go directly to it, chat. It will go directly to it. Also, we have... Oh yeah, the creeper, chat, from last stream. We have here, chat, summon creeper, and we have commands, and this is one of the commands. We can summon the creeper, and we managed to implement pathfinding. So basically, and using the A* algorithm. So basically, if we create a maze, like if we bring the creeper down like this, and here we create a maze, we need to go towards here. We'll have towards here. We'll have towards here direction. And let's say we give it a goal to reach here. This will be the goal. And it found this path, chat. So it will go here, it will go here, it will go here. And this is the end, chat. Or if I pick the end to be here, look at this, chat. It goes through here, and it reaches here, the goal. So in the previous stream, we managed to do pathfinding. There's one issue, chat, with the pathfinding algorithm, is if we set the goal to be above the creeper Y level, it cannot reach it because we haven't implemented jumping. And there's another problem with this feature, is if here, for example, it needs to go down, the pathfinding will ignore it. It's very simplified, just so we can be sure it works. We've left more complicated implementations for the future. Maybe in this stream, we'll see if it's going to be in this stream. Also, we added game modes. So currently we're in creative mode. But we can go in survival. And in survival, we have this basic inventory where you just have the item slots here. These item slots do not work. The crafting here doesn't work. And the Steve doesn't follow the mouse. He's just a regular image. Just so we can have something to work with. We'll improve it at some point, but this is survival mode inventory, and we don't have health and hunger. We may add it this stream, we'll see. We may make the creeper start following the player. We could try to do that as well. Let's go back in creative. We have the crafting table, which is still broken here. We have a pause menu. The pause menu, we can see it in the crafting menu as well for some reason. But here we have a pause menu, and if we jump, it pauses the entire game, and we can go back in game. You can go back in here, crafting. You can put items, but we don't have crafting recipes as of yet. We don't have recipes. Anything else? We have F5 mode. So we could focus maybe on animation. Steve, the animationless jump scare. Steve is not animated. To make multiplayer compatible with Minecraft servers, this is something for in the future. It's not for right now. That's an idea for the future. Okay, so what else did we do? Lava is the same. Lava is just simple. We haven't fully implemented the lava. We can copy the logic from the water and slightly change it. We have farmland as well. Okay, I'll place the farmland. I'll place it, and while it's growing, we'll decide what we're going to do in this stream, chat. And chat suggestions, I will keep them with I'll listen to them with a grain of salt, because last time chat voted for mob pathfinding, and then most of people left once I started implementing the A-star pathfinding algorithm. So chat sometimes is not sure what it will get when it votes for something. And here we have the debug menu, and here we have block states, and you can see this wheat is already of H1. It's actually growing. You can see there's a bit of a difference. So this is kind of a summary, chat. This is kind of the summary. So while this is growing, we'll decide what we're going to do today. We'll open a notepad here. We'll open a notepad and we'll decide what we're doing today, chat. So let's brainstorm ideas, chat. We could fix physics. We can fix physics. We can finish creeper. Make creeper follow player. We can finish the creeper. Items in hand. Items, to have items. What else can we do, chat? Water fix. We can fix the water. Lava plus water. The stone generator, cobblestone generator we could do. Let's open from previous stream ideas, just in case. Here we have from previous stream ideas. From day-night cycle, nether. Oh yeah, item drops. We can do item drops. Crafting recipes. Crafting recipes. Day-night. Cats and dogs. Ores. We can do ores. Villages, because to improve them, to improve villages. Our first approach was not the best. Health and hunger. Health and hunger. Villagers. Make it rain. Minecraft does not have per face lighting. What do you mean? You're talking about smooth lighting. Are you talking about smooth lighting? Fix leaves graphics. What else, chat? We want ideas. 3D clouds. 3D clouds. What else could we do, chat? Lighting. Thunder. Snow. Oh, I forgot to show you the rain. We have rain. We can have rain. It's per face lighting, and you can do a simple experiment. You can do simple experiment, chat, for the lighting debate. For the lighting debate, you can do a simple experiment where here you can have like this here. Let me see. How could we do it? So here it should be dark. Oh, we have the night vision. We have the night vision. So let's go in a different world. This is survival. Creative mode here. Bro, we have so much redstone here. I just want to see the debate of the I do per face lighting. I don't do the whole. No, I don't do any lighting. In my Java clone, I have lighting. Currently, I only have ambient occlusion, but we can test this, chat. We can test this. So here, if we have. So you can even do it like this, chat. Look at this block. This block currently above it is lit up, but below it, here it's darkness. Here it's a lot darker. We can go even darker, chat. We can go even darker. So what do you mean it's not per face? Here, this side is the darkest. And in the same block, here is bright. What do you mean? I don't get the debate, chat. I don't get the debate. Okay, we have, maybe we have enough options. Maybe we have enough options. We could do a poll. We could do a poll. Let's do a poll, chat, on what to do during this stream. Let's create a poll. Pop out chat. Let's create a poll on what to do during this stream. Never mention light level. Let's start the poll here. What to do today? We may experiment having two options in the poll. We may do an experiment like that of having two options in the poll. Items. Fix water, physics, day, night. Creeper follow player. This is one option. Fix water. Water mesh plus lava. We could add a third option, ores or day and night. Items, yeah, items. And let's do item drop and hold item in right hand. Let's do a poll, chat. Let's do a poll and see what you guys want. Sometimes viewers don't know what they want because last time they voted creeper pathfinding and everybody left. So let's take with a grain of salt what chat votes. Let's take with a grain of salt what chat votes. So here are the options. Currently we're voting what we're going to do in this stream. The options are the creeper to follow the player. Because we implemented pathfinding in the previous stream, it will be very easy to make the creeper follow the player and explode. I don't know why viewers are not picking the creeper. It will be very easy, chat. Water mesh plus lava. Yeah, the mesh looks pretty ugly. The mesh looks pretty ugly. We could fix it, the mesh. It wouldn't be that hard probably to fix the mesh. And to have the lava work like the water. And item drop, we can generate the mesh. We just need to have an entity for the item that we're throwing. Hold item in right hand. Again, we can generate a mesh. We just need to render it where the hand is. Okay, let's end it. Let's end it. So chat decided to, what did chat decide to do today? We voted for water mesh plus lava. Okay, let's do it. And if hopefully we'll have free time to do other feature as well. I don't think this will take too much time. I don't think you can don't quote me on this, but I think it will not take that much time, chat. I don't think it will take that much time. Wait a minute. Okay, let's start this. Okay, let's start this. Oh, chat, this is the new feature of the stream. This is the new feature of the stream. Inventory scroll bar, creeper pathfinding. Okay, let's test this. This is a new feature of the stream. Chat, what do you think of the new feature? It created my bot created a poll. It created a poll where you guys can vote your favorite feature of the recap. Creeper pathfinding, water spread physics, TNT random sounds. Nobody cares about TNT random sounds. And inventory scroll bar. Why doesn't chat like inventory scroll bar? Bro, that's my favorite feature. Here, inventory scroll bar. Bro, why does nobody care about it? Okay, so chat voted for us to implement the mesh. Chat voted for us to implement the mesh. Let's actually implement it. So like we already pretty much have it. We just need to improve it and to give it to the lava and maybe to create the cobblestone generator. Maybe to create the cobblestone generator as well. Okay, let me go down. This. Let me go down. Bro, my green screen is showing. It's barely holding up. Okay, chat. So we're going to do the water. Let's do the water. So, like every stream, we open Minecraft for reference. Let's open. Yeah, we can do it here, chat. We can do it here. And here, let's just spread water, just to compare our current result with this one. So chat voted for us to fix the water. As we can see, currently the water, let's remove sound. Currently the water, this is the water in Minecraft. This is the water in Minecraft. And this is it in my game. This is it in my game. Let me leave it here like this. So this is it in my game. You can notice there is a big difference, but we are not that far away from implementing it, because you may not know that, but we can pick for every water mesh, for every water block, we can pick each one of the 4 corners, how much height it should have. So we have the functionality to have the same water as in Minecraft. We have the functionality, we just need to make it, to figure out how they actually do it, because you can see here, it's not as straightforward as just doing a naive approach like this one, where I've just set all of the 4 corners to have the same height, depending on the water level. But here you can notice how it's different. Here the diagonals, here look at how these ones are the same. This is a lot lower and this is the highest. But here this one is flat. And this one, the diagonals are not, they are different now. Here these ones are the same and these ones are the same. So you can see how it's a bit different in Minecraft. So what I'm wondering is, should I do the water? Should I do the water to try to do the mesh? Or should I make first the lava be just like the water? I'm not sure which one of the two. Or should I fix this problem where when the water prioritizes going down, it's doing it too well. It's too restricted. It needs to split somewhere here, chat. So chat, what are you thinking? Should we make the lava be like this water, or should we like start with the water? Make lava, then just make for both of them. It will be faster, I guess. Lava will be easier. Lava is easier. Water. Start with water. Chat, I need 1 minute. I'll be right back. Need 1 minute. So what did chat decide? Lava is easier. Water, start with water. Do lava. Water. Make a poll on Twitch. We're not doing a poll. If prioritize be same for both, then it would be logical to make lava first. Should make common system for fluids. Water. Okay, we'll do the water. Because, chat, it's fine, chat. It's fine if we don't do the lava as of now. It's fine if we prioritize the water to make it be more like Minecraft, because it should be easy copy-paste. For the lava, we will just need to change some parameters. Because if we look at lava, it acts almost in the same way. It's almost in the same way. It's maybe a bit slower. And it doesn't spread as much. Maybe it doesn't spread as much as the water, chat. So it should be pretty much the same. Yeah, it's pretty much the same, chat. It's pretty much the same. But wait a minute, as I think about it, I think lava will be easier because it doesn't spread as much. It will be the same, but easier. It doesn't spread as much. It will be easier to debug. Let's do lava. The logic is the same, but I think it will be simpler to do it. Because here, because it can go further distance, it's a bit annoying when working with it. But with lava, it should be easier, chat. We can actually do the lava. We can do the lava. Yeah, let's do the lava, chat. Let's do the lava. Okay, we'll make the lava spread as well. And we'll have the mesh be just like in Minecraft. We'll have the mesh be just like in Minecraft, like this. And once we have this lava, we'll implement the water as well. Which should be very simple. The most difficult part will probably be the animation at the top, because we need to change the direction of where the water is flowing. We need to change the direction. And also, let's create a timer, chat. Let's create a timer here. No. Let's create a timer. And let's do 15-minute timer just to see if this is too difficult for us or not. After 15 minutes, we will decide. After 15 minutes, we will decide if this is too difficult for us or not. Because sometimes it's much better to just move on to something else. So let's give it 15 minutes and see if it's too difficult to do it. Okay, let's start with the lava. Let's start with the lava. Let's make the lava spread. So where is my code for spreading? When we implemented the water spread, we implemented the tick system, chat. We implemented the tick system. Where is it? So for all of the blocks, yeah, here, farmland, water, here, on tick update. This is it, chat. The on tick update. On tick update. What does this function do? This function is called like every 5 ticks, I think. Every 5 ticks. Oh, guys, in Minecraft there is a cool feature where you can slow down the game. You can do tick rate 5. And when you place lava, it will spread very slowly. And we had an idea yesterday in the previous stream to implement this feature, to slow down the game, because it will make it easier to implement the features. It will make it easier. Should we implement a slowdown of the game? Should we implement that? Will it be worth it? Will it be worth it if we do it? And we have another feature here in Minecraft. We have a shader that shows the wireframe, chat. This is also a useful feature. We can show. Should we also make it possible to look at the wireframe in our clone as well? Will it be of use, chat? Will it be of use? Will it be? Yo, wait a minute. Game mode spectator. Wait a minute. I haven't seen a diagonal like this, chat. This one is a bit different. This mesh a bit different. Yo, what happened? Yo, thank you for a super chat, man. I appreciate it. Thank you, man. Thank you for supporting the stream. Thank you, man. Finally, I did it. Why didn't you use OpenGL? We're using OpenGL. Raylib uses behind the scenes OpenGL, and we can directly use OpenGL. What's up with the physics? What do you mean? Let me think about it, chat. The reason I'm currently surprised and frozen is because of the mesh here. I'm surprised by how the mesh looks like. I'm surprised by how it looks like. No, I was just, the confusion came from the rails. The mesh of the rails is overlaying over the lava. That's why I was confused. Because the mesh looked to me very weird, it's fine, it should be fine. We should be able to implement something like this. So how should we approach it? Okay, so what's the first goal, chat? What's the first goal? Yo, thank you, man. Thank you for, I don't know why everybody today is feeling like supporting. Thank you, man. I appreciate it. I appreciate it. Thank you for supporting, man. Hype train, I guess. There are no hype trains in YouTube. Only on Twitch. 20 of something. Okay, let's decide on the first goal to implement, chat. Let's pick a first goal to implement. Let's decide on a first goal. I think the first goal would be to make the water, the lava just like the water with the simple mesh, and to make it spread a lot less. This should be the first initial goal. Chat. This should be the first goal. How should we have something like this? How should we implement something like this? We can just copy the same thing we did in the water, maybe with new changes, because we'll be making it like Minecraft and not this simplified. So let's see the code for the water, chat. Let's see the code for the water. So we have on placement. When we place water, it will queue tick update after 5 ticks. That's the only thing that happens when we place water. That's the only thing that happens. And after 5 ticks, we run this function here. We run this. And what do we do here? This is some kind of a lambda function. We don't care about it. We look at below us. We look at the block type below. Sure. Block type below. This is for deciding if we are going to place water below. Oh yeah. Here we have the code. Yeah, here we have code for searching for holes. Searching for holes. Because when you place lava or water, tick rate 20. Here water, and if we have a hole here, it prioritizes going towards it. Is it the same with lava? Do we need something like this? Oh, it's the same with lava? I'm surprised. Let's ignore this. Let's keep it extremely simple. Let's ignore that. Let's ignore this. Let's implement something of our own. Let's create a new class for the lava. We could make it just a liquid, chat. We can abstract it away in a liquid class and the lava to just inherit it. We could do something like that. I want them for now to be separated. We'll separate them once the lava is done. Once the lava is done, we'll then create the liquid abstraction and we'll just inherit it from both the water and lava. And we'll just change some parameters. Let me think about it. So, okay, chat. Here, let's just copy this water structure and place here just lava. Here, lava, like this, chat. Lava. We'll have here on placement. We'll have on placement, which will be the same. It will be the same. Maybe with a slower tick rate. So the lava to spread a lot slower. So here we do lava cube. No. Here we cube block tick update and it will be after every 10 ticks. After every 10 ticks, it will do it. For generating the mesh, we'll copy the same code. We'll copy the same code. Here, generating the mesh. Wait a minute. We already have a lava class. We already have a lava class here. This one, bro. We already have one. Now we'll replace it probably. Let's replace it. Here. Where did it start and end? I forgot. Like, copy the water, generate mesh. And place it for the lava. This is for generating the mesh. This is for generating the mesh. We don't want a color overlay. We don't want an overlay. We'll keep it just the white color. We'll just keep it the white color. Like this. And what else? What else? Oh, we need to give it a state, chat. We need to give it a state, the lava, to have northeast, northwest, southeast, southwest height levels. This is for generating the mesh. For generating the mesh, we can easily give it block state by going in the resources blocks. And here we'll just copy the water. We'll copy the water. And we have if it's still or not current layer. The current layer and the flow direction. We're not currently using the flow direction. We're not using the flow direction. See-through, semi-transparent, we don't care about that. Let's go to the lava. Here, the state. We'll have it have this. Like that, chat. Like that. So now the lava has block state, just like the water. We'll make a parent liquid. Yeah, but not right now. I don't want a parent liquid as of now. We'll do it at the end. So this is the lava. This is color overlay. These are the heights of the four corners. And here we load the liquid mesh. What's this function? Oh, but it uses the water block. It uses the water block by default, chat. Okay, what's up? We need to change it. Let's directly change it to use the lava block, to use the lava block here. Or we can just check it here. If block ID equals water, it will be like this, else it will be lava. It will be lava. Lava, like that, chat. It will be like that. It will be like that. Then we generate it. That's it. Okay, so we don't need all of this. We don't need all of this. And what now, chat? What now? We can generate a mesh. Where's the block? Here. Okay, this is the lava. We have on placement, perfect. We have generate mesh, perfect. On tick update, we'll do nothing. We'll do nothing. I want to just run it and see what do we get as a result. Yeah, let's just run a chat. Let's see what do we get as a result. Let's spawn lava. It should be the same as before. Okay, perfect. Perfect, it's the same as before. Let's now make it spread. Let's now make it spread. Let's make it spread. So after 10 ticks, we'll get this update here. This function will be called. What do we need to happen after 10 ticks? What should happen after 10 ticks, chat? Do you plan to prioritize chunk loading in the direction you're facing? I plan to do it, but not right now. But that's when we improve the frustum culling. That's when we're going to do it. Because currently the frustum culling is not perfect. When we're gonna work with rendering, finishing steps, what do you mean? What should happen after 10 ticks, chat? I want to keep it simple, chat, because in our water code, in the water code, we did too much. We did too much in our water code when we implemented the water. Here on update, here we have too much code, chat. I don't want this much code. I don't want this much code. This is too much code. I want for lava to try something else, something simpler. How much time do we have? Okay, the 15 minutes are over, chat. Should we continue or switch to something else? Just want to be sure, chat. Should we continue or switch to something else? Switch to another feature. Yes, no. 15 minutes are over. The 15 minutes was just to see if it's too difficult or not. If it's too difficult or not. Will it be too difficult? Well, it will be very easy. It will be very easy to make it just like our water implementation. It will be very easy. Here, the water. It will be very easy to make it like this mesh. It will be very easy to make it like this, the lava. What I'm not sure about is generating this mesh, chat, connecting them. We can easily do it because we have the implementation. We have the implementation to do it in the code. We just need to tell it, here the water, we need to tell it, okay, this water block, you need to move these vertices at this height level, and you need to move these ones at a lower height level. I need to decide how are we going to calculate the height level. Once we have the height level, we can easily use it. We can easily use it and render the mesh. Okay, we're continuing, chat. We're continuing. We're continuing. Okay, we're continuing, chat. So let's do 1 hour timer. Let's do 1 hour timer. Let's do this, chat. We're locked in. Let's fix the fluids. And let's rename the title to be, renaming to be Minecraft clone. YouTube is having issues. I just want to change the title. Title will be implement fluids. Fluids. Like this. Implement fluids. Okay, chat. So for the fluids, look at how they go down. We don't need all of this complexity as of now. of the water. We don't need all of this complexity. We need it to keep it simple. Here, look at this chat. When I place water, it goes down, it looks for here a direction of going down. It looks for below it a block that is broken. Air. It looks for the block type of air or just foliage. If here is foliage, it's also okay. Or if it's another water block. And here, look at how, again, it prioritizes the cave. And here, it actually spreads. We don't need all of that for the lava. For the lava, I want to keep it simple. Just on the same axis and to spread very little. To spread. Oh, I have an idea, chat. Chat, I have an idea. In Minecraft, when we slow down the game tick rate 5. This slows down the game a lot, like 4 times, probably. Look at what happens when we place lava. Look at what happens on the first update. Like this. And let's do a screenshot. This is what I want to implement. Only this, chat. We'll keep it simple as possible. So excalidraw.com. Where's the cursor? This is the cursor. This is Steve. This chat. We'll keep it as simple as possible. Let's implement this mesh, chat. Let's implement this mesh. We'll keep it as simple as possible, and then we'll implement the other mesh. We'll implement the other mesh then. Oh, this is very simple. This is very simple to implement. Here, chat also told me let me think about it. Tick rate 20. We don't need to slow down the game. Another thing we can do is tick freeze. We can freeze the game. We can spawn the lava, and here we can do tick step. Tick step. We need to step like how many ticks? How many ticks do we need to step? Chat, when does the lava update? How many ticks do we need to go through? Let's do 5 ticks. Bro, even 5 ticks? 30 ticks? So it's 1, 2, 3, 4. We did 21 ticks. We did 21. So let's do 9 ticks. Okay, it's 30 ticks. Bro, it's 30 ticks. So let's change it in our game. The lava to update every 30 ticks. Let's do the same in our game. Here the lava on placement, I want an update after 30 ticks. After 30 ticks. Oh, thank you for the suggestion. Chat, they told me to look up Minecraft parkour wiki player movement. Player movement. Parkour wiki. Yo, this will be very useful. Jumping, sprinting. Okay, this will be useful, but not right now. But I'll save your suggestion. It's a W suggestion. Here, it's a W suggestion. Thank you. Thank you, thank you. For fluid mesh, you could implement a dynamic system that adjusts the corner height of the mesh based on neighboring blocks. I already have that. Like I have the system. I haven't made it dynamic, but I have the system. So this is in Minecraft currently. This is in Minecraft. This is our goal to implement the fluids. This is the goal to implement the fluids. And we have the simple fluids. Let me look at this chat. Let me look at this. And here you can notice how in my game I've separated them into blocks. Yeah, look at how here it increases a little bit. Do you notice? It increases a little bit. But I don't care about that. We don't need to overly complicate it. So currently I've made it so in my game this right here is one block. And this right here is also one block. This is also a separate block. And this is a separate block. For each one of these blocks, I can pick the height level of each of the vertices. I can pick the height level of each of the vertices. And it will actually update the mesh. You misspelled fluids in the stream title. I'll fix it at some point, not right now. So how should we do this, chat? How should we do this? I want to keep it like this. We've simplified it to not have it like this, where it spreads out everywhere. We'll keep it simple and just do this, chat. We'll just do this simple mesh. And let's do it on placement. Let's do it on placement, chat. Let's do it on placement, I think. No, let's not have it on placement. I was thinking to do it immediately when we place it to get this. But it's fine. We can do it to update afterwards. We can do it to update afterwards. So how should we approach this, chat? So when we place this block, it will get updated after 30 ticks. So that's a bit more than a second. So after a bit more than a second, this block will get updated and it will spawn these child nodes. So let's do something like that in the game as well. Let's do something like that. So here, this is currently what we have in my game. In my game, we just have this block. We have here water as well, but we are doing a simpler version with the lava. I think the way to do it, we need to keep it simple. That's the way to do it. Just keeping it simple. So let's get a little bit of inspiration from the water. Let's get a little bit of inspiration. So in the water, what do we do? What do we do in the water? What do we do, chat? Here we search for something. Oh, this is placing the water. We have here a function that places water for us. Yeah, we have a function for that. And here as well, we have a function that decides where we're going to place water. And what's this? This difference is the flow direction. This is the flow direction. And this is the layers. The water spreads with -2 of the layers. The lava will spread it even more, chat. With an even bigger difference, we'll spread it. Okay, we'll do a function like this for the lava as well. I like this function. I like it. We'll have something like this for the lava as well. Let's copy it and let's use it for the lava. On tick update, we'll have it be here. Place lava. Place lava. We'll have a position where we're going to place it, a flow direction, and isn't this the parent layer? Isn't this the parent layer? Oh, this is the current, the block we're placing the layer. Here, when we place a block, this we just need to change it to be lava. Here we just place lava. That's it. And let's place here. Let's place here. Let me think about it. And here this needs to be 30. We need to actually place the lava. Where should we place it? Yeah, let's place it to all of the neighboring directions. Let's do position details neighbor equals the current position get north, and then get south, and then get east, and then get west, and for all of these we'll do place lava at this neighbor position. We need flow direction and the layer. How did we calculate that? Here, this difference, and it's normalized. So if we go to the lava on tick update here, let's calculate the difference. Calculate this. We need to calculate it multiple times. Makes so this is the difference. We'll do the difference between the neighbor. I think, chat. We can calculate the difference ourselves. In the function. We can do it in the function. Let's do it here, chat. Let's do it here. Let's do it here. While Petsa Codes chat is talking about emojis. It's fine, chat. It's fine because we're currently trying to go through the boring part for chat. For me, it's not that big of a deal. So here we need to calculate the difference between the parent liquid position and the child liquid position, so that we can get a flow direction. So here we do this naming is not proper. Neighbor position. And here we need reference to the parent position. Position details. So let me think about it. And here we need to rename all of these references. All of them like this. This needs to be neighbor position. Like this. And here this will be the parent position block origin. And here we calculate the flow direction of the water. Here we'll calculate the flow direction of the water, like this, chat. And so here we don't need to give it. Here, flow direction, let's remove this, chat. We don't even need to give it this probably, but the child liquid, we can give it a layer as well. So here we can give it the neighbor position, and for layers we can give it the current layer. What should we give it, chat? Oh, we are not getting the current layer. We can easily get it just like we got it from the water here, layers. like this, chat. Very simple. Here, layers, like this. Okay, we have the current layer. So the child layer will be layers minus how much? So let's say the origin, when the lava starts, let's say the layer is 16. And let's half it for the lava. Let's shorten it a lot. Let's even make it even less than half. Because here in Minecraft, okay, how it drastically lowers, chat. This is like, I think it's like going from 16 down to 4 maybe. Let's do down to 4. So here let's just directly give it to be 4. Directly to give it to be 4. Like this, chat. And here we do it if the current layer, if layers is, how should I call this? If layers is less than 16, we return, we do nothing. Because I just want this. I just want this initial spread just to keep it simple, and then we'll make a spread again. Can you turn your volume up a bit? What do you mean? Oh no, volume is fine. Turn it up on your end. Volume is fine. There are helpful extensions where you turn up volume even more. Okay, let's test this, chat. Let's test this. It should be enough. Let's see the result. Let's see the result, chat. Let's see the result. The debug green outline in Minecraft is from a resource pack, shader. It's from a shader. For Fuilds mesh, you could implement dynamics. Yeah, we already read that. In the nether, lava moves faster and extends as much as water. Thank you for that. Thank you. Okay, let's place the lava. Let's place the lava. And let's wait 30. Yo! It's like a hat, chat. It's like a hat. It's actually working. It spreads from 16 layers down to 2 layers. No, down to 4 layers. This is 16 layers. It spreads down to 2 layers. But the mesh, it has gaps. The mesh has gaps, chat. It has gaps. We could connect them, chat. This is the next step. This is the next step to connect them. Because if you look at Minecraft, look at how here is the same thing, chat. Trust me, chat, is the same thing. But look at how here they just connect them. The connection is very simple. The children just need the start positions to be way higher and the end positions to be way lower. So let's do something like that here. I have an idea how to do it. How should we do it? I don't care about the texture on the site. I don't care about texture on the site. So here we go towards the north. We go towards the north. Here, when we go towards the north, I want the south to be higher up and the north to be the lower. The north to be lower. So here, when I first do this, I want to change it here. No, chat. I could have it here implemented, here as an argument. I can have it here as an argument. So here we can do integer. Northeast height. Northeast int, what else? Northwest. And then we do southeast. And then southwest, like this. Here we change this to northeast, northwest, southeast, southwest, like this. So here it will be very simple. Here, this is towards the north, So we want the north to be, let me think about it. The north will be the lowest number, and the south will be 16. Here, this is towards the south. So towards the south, we want the north to be higher up and the south to be lower. Here towards the east, we want northeast to be lower, southwest to be higher, southeast to be lower, southwest to be higher. Here towards the west, we want the east to be higher, like this, chat, like this. So this should be just like Minecraft. It should be like Minecraft. Let's see, let's get our lava block and let's spawn it. Let's wait. Yo, chat. Let's make a screenshot. But this stays the same. It doesn't spread. Yet. We need to make it actually spread and to continue the logic, the spread logic. Let's update the thumbnail so everybody knows what we're doing. Update the thumbnail like this. Done. There's chat. Okay, so we have this spreading of lava. And we have this spreading of water. Look at how this was the first attempt. The first attempt from a previous stream gives us this broken mesh. But we changed it to be like this. But sadly, it doesn't fully spread. And the textures are stretching here. Textures are stretching. We need to change the UVs to be better mapped so they don't stretch as much. But we should be getting similar mesh just like in Minecraft here. We should be getting a similar mesh. We need to actually make it a bit lower to not be a full block 16 because it's actually here a bit lower. It's actually a bit lower, 14 instead of 16. That's why in my game it looks a bit higher. In my game it's a bit higher. So what should be the next step, chat? What should be the next step? The next step would be to continue the spread. Because it doesn't stop up to here, it spreads even more. Here, if we go by another tick step, if we go another 30 ticks, look at it, continues the spread, chat. It continues the spread. So this is the next part we need to implement, chat. This is the next part we need to implement. Is your lava source block a full block height? Yeah, it's a full block height, but we can easily change it. How should we go from this to this? What's the difference, chat? Okay, let's first do this change, chat. Instead of having the lava be full height, let's have it be a bit lower. So for the starting height of the lava, let's change it to start from 14 and here 14. And in the block update in the lava here, everywhere we have 16. We'll just have this be the parent height level. Okay, let's pound the lava again and let's see if the height level is different. Okay, height level should be lower, chat. Yeah, look at this, chat. The height level is lower. Maybe we need to make it even lower because this is pretty close to the full height. This is pretty close. In Minecraft, how much is it? In Minecraft, it's even lower in Minecraft. So maybe instead of 14, 12. Let's make it be 12, chat. Make it be 12 to make it even lower. So in the lava, where is the lava? Here, lava. Make it be 12 by default. Make it be 12. How is it now? Oh, now it's pretty good. Now it's pretty good. Let me think about it. Currently, we need to decide how should we go from this here. How should we go from this to this? This is the current problem, chat. How to go to this? This is the current problem we are struggling with, chat. This is what we're struggling with. Something in the thumbnail while we're thinking about it, because it's not easy to decide how we're going to tackle it. Something in the thumbnail be the improve one done. Where is chat? Here is chat. Here is stream. How should we do it, chat? How should we do it? We only have the first spreading. We have only the first spread, chat. We improved a lot because with the water, our water attempt is not the prettiest. We improved a lot during this stream. We improved a lot, but we can improve even more. We're not done. This just spreads the water, the lava once. We need to spread it again. We need to spread it one more time. So basically, we would need a block here, 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 here. So basically, we need to spread it again. We need to spread it again. And how should the mesh look like when we spread it again? How should it look like? Game mode spectator. How should it look like, chat? How should it look like? Water has good physics, but bad look. Lava has good look, but bad physics. Yeah, you're right. So here, okay, what's the difference? Let's look at the difference, chat. Here, we can notice this diagonal is different than these ones, chat. When the flow direction is straight, it's very simple. When it's diagonal, it's a bit difficult. Oh, I have an idea, chat. We already calculate the flow direction automatically. We just subtract. Oh, wait a minute. We just look at the parent. We just look at the parent for the flow direction, but that's a mistake. We need to look at the source, the start here. We need to remember where all of this started from to calculate the other meshes. Probably it will be annoying because we need to pass additional information. Could we do it in a different way? We could just look at the neighboring blocks. We could just look at the neighboring blocks. If we look at the neighboring blocks, this block will look at the neighbors and it will figure out it's a diagonal block from its neighbors. And this block, it will figure out it's flowing downward just by seeing it has only one neighbor behind it. What about this block? This block has neighbors to the left and right and behind it and to the front of it. But using the layers, using how much layers the lava is, it can figure out the flow direction maybe. Let me think about it. Here, with the lava. So when we place water here, we have the fluid system pretty good. We ignore the mesh. And now with the lava, we are focusing just on the mesh and the fluid system is very bad. Because it stops up to here. We need to spread it once more. We need to spread it again. How should we do it? Chat? Oh, I have an idea. Let me think about it. We could not bother with the mesh. What do I mean by that? We could ignore the mesh in the tick update. First to do the tick update, and then to call another function that updates the mesh after the tick updates. Let's open. Thinking to open it here. I'm not sure, chat. Okay, so we are currently blocked from progressing further. What's the best strategy to break free from this blockage? Because we don't have all of the time in the world. We have an hour. How much we have time left? We have 24 minutes, chat. We don't have all of the time in the world. We don't have all of the time in the world. What should we do, chat? We're currently blocked. We can just do an attempt just to move forward. Let's just spawn the other neighbors as well. Let's just spawn them because currently we stopped the spreading. Use water logic you made. I cannot because water logic we prioritize the fluids, not the mesh. Right now we're doing it differently for the lava. Let's do this, chat. Let's spread them once more. Because we limited the spread to be up to here, let's continue the spread up to here. And for the mesh itself, we'll figure it out. We will figure it out. Let's not be stopping so much. Let's not be stopping so much. But currently it looks very cool. And we're ignoring textures. If we did textures, we would focus here the animation to flow down and here to not be stretched. Because currently it's the still lava animation. Here is the flowing animation, but you can notice how all of them are the same direction. Wait a minute. This flow direction and the animation, I think it can help me actually. Because when we spread, this will have a flow direction up. Yes, let's do that. Okay, chat, I changed my mind. Chat. We'll have the flow animation. And we'll have the flow direction be saved in the block state. And we'll actually change the animation flow direction based on the direction of the flow. This will help us with the spread. I think this will help us, chat. Okay, let's first change the animation to be flowing. How should we do that? Maybe first to do a commit. Simple lava flow first stage. One stage. Push. The lava block, here it will use the lava flow animation. To use the lava flow. And look at this, chat. It's flowing, chat. It's flowing, but we need the proper direction as well. Because currently it's flowing towards the south direction. All of them. It's flowing towards the south. Here it's flowing down, actually. It is flowing down. Chat, why are we talking about advice on YouTube? Chat, how did you switch to advice to YouTube? Check all corners for the height and make it go from the highest to lowest edge. You mean the flow direction? No, I'm doing the opposite. From the flow direction, I'm changing the height levels. I'm doing it opposite. Let's actually save the flow direction, and when we're rendering it, let's rotate the texture depending on the flow direction. Chat. Let me think about it. How should we do this? How should we save the flow direction? How should we save it? Chat, do you know how Minecraft saves the flow direction? Because currently of the lava, I save the flow direction as an enum. I just save it as an enum, which is a mistake. It's a mistake because the flow direction is not only towards the north, south, east, and west. It can go diagonal. As well. We could do two integers. No, we could do two floats. Or maybe to have two booleans. Or like two integers. And to act a bit like booleans. So for the x-axis, if it's positive, negative, or neutral. And for the z-axis, if it's positive, negative, or neutral. And that's how we could save the flow direction. Because I don't want to use floats. For the block state of the lava to save the flow direction. Or chat. Or we may not even need to save it. We may not even need to save it, chat. We could just calculate it from the height of the 4 corners, just like chat told me. We could just calculate it through the corners. We may not even need to save the flow direction. And if it's still or not, we don't even need to save that. It's still if all of the heights are the same. And I need the flow direction in order to have the animation working properly. Yo, look at how the animation stopped working once we stopped the tick update. We stopped the tick update and everything stopped working. Chat, look at this. The particles stopped updating as well. So the particles are using the tick update. That's interesting. And the animations are using the tick updates. I didn't know that. That's probably for optimization. That would be useful for my game. That would be useful information. But let's focus on the fluids. Let's focus on the fluids. Let's stand up as well. Yeah, let's focus on the animation, chat. Let's focus on the animation. Let's focus on the animation. But let me change the camera. Okay, let's focus on the animation. Currently, how does it look like? Yeah, we need to rotate the texture, chat. We need to rotate the texture. We need to rotate the texture. Currently, all of them flow towards the south. All of them flow towards the south. Let's change it. This is the current goal, chat. This is the current goal. Yeah, tick rate system optimizes the game a lot because you can run code every second. You can run code every 0.05 seconds instead of every frame. Every frame is a lot faster than every 0.05 seconds, which is Minecraft runs at 20 ticks per second. So one tick is 0.05 seconds. It helps a lot with optimization. Just use AI. You need to go. You are banned. Sorry, man. Okay, chat. Let's focus here. Let's focus. Let's change the flow direction. Let's have the flow direction depend. The flow direction to depend on the heights of the 4 vertices. Here it's obvious. It needs to go towards here. This is obvious. It needs to go towards here, and this towards here, and this needs to be the still texture. This needs to be still. This needs to be still. Where will we have this code running? Where will we run this code? How much time do we have? An hour and 30 minutes. We're doing good on time. Where should this code run, chat? Where should the code run? Let's find a place for the code, chat. Let's find a place. It's when we generate the mesh. It's when we generate the mesh. Here. Here. Yeah, here we set corner height level. We set corner height level. We need to also set rotation for the texture. Rotation specifically for the top texture. That's what we need to do, chat. Specifically for the top texture. Animations per tick. How are we going to do the rotation? How are we going to do the rotation? Can we do it from here? Cube mesh pool data template. And then here, rotation, rotate texture, or top rotation. Perfect, chat. Top rotation. Interesting. But we don't have diagonal rotation. We don't have diagonal. Here in Minecraft, they have diagonal rotation. That's interesting. Let me think about it. How should we do the rotations, chat? The default, what was the flow direction by default? What was the flow direction by default? What do you mean just rotating on both sides? What do you mean? Here by default is towards the south. Yeah. By default, it flows towards the south. By default. By default, it's towards the south. So here, by default, towards the south. So if let's do it like this, chat. Let's do it like this. If how should we calculate the new flow direction? So how should we have the new flow direction? How should we calculate it? Because we only have 4 integers. We just have 4 integers, and we can calculate the which one is bigger, which one is smaller. That's the only thing we can do. We just have 4 integers. How will we get flow direction? Here it's simple. If these ones are the highest and these ones are the lowest, the flow direction is towards there. It's simple. But what about the diagonals? Diagonals? I'm not sure. Not sure. How to get a direction? How to get a direction with 4 integers? How to get a direction with 4 integers? Okay, let's simplify. How are we going to get a direction with 2 integers? If we had 2 integers, how would we get a direction? Well, let's say the first one is the number 2, and the second one, let's say the first integer is the number 0 and the other is a number 1. So when the second one is higher, we go to the positive. If the first one is higher, we go towards the negative. If they're the same, we stay the same. We stay still. So how is it with 4 integers? With 4 integers, look at here, in this case, it's simplified to just 2 integers because these one here are the same. These one here, bro, game mode, creative. These one, let me remove this. These ones here are the same here. These ones here are the same height, and these ones are the same height. We can look at them as just 2 integers, which makes it simple. But here is again 2 integers. These ones are the same, and these one are different. So it's always 2 integers. They're always 2 integers. How should we do this, chat? I have no idea how we should do it. Okay, let's keep it simple. let's do it very simple. Let's do it very simple. By default, it flows towards the south. So let's cover the other case. Let's cover the other case. Here, what should we do for flow direction towards the north? How should we do towards north? When are we flowing towards the north? Well, if northeast height equals northwest height, and the same for south. The same for south, and if north, any one of them, if the north is, this is towards the north, if the north is lower than the south. Like this, chat. And here we rotate the texture. Here we rotate it. But here we have some kind of an issue. What's the issue, chat? Here, this expected. What's the issue here, chat? Here, some kind of compilation error. What's the error? What's the error here? What's the error here, chat? Northeast height. Maybe the naming. Yeah, it's the naming. Yeah, typo in height. Thank you, man. Thank you. So here we just rotate the texture. So by default it's towards the south. How much should we rotate it? We need to rotate the top texture. Here, top rotation equals 180. Let's do 180 and let's test it. Let's see what the result is. And we'll do the still animation as well, where it shouldn't move. Okay, let's see what the result is. Let's see the flow direction. This is towards the south. Yo, look at this, chat. Towards the south, it goes down, and towards the north, it goes down. That's perfect. Now we need to make this block be still. This needs to be still. We need to cover towards the west and the east. The problem is when we reach the diagonals. That will be a problem when we reach the diagonals. Could we make it simpler, chat? Could we make it simpler? Oh, chat! We can have the flow direction be a rotation. By default, the angle to be towards the south, just like we did it here. By default to be towards the south, and to save the flow direction as a rotation. As a rotation, yeah. And it will be a single integer. And that's it, chat. That will be very helpful. Because I don't want to always calculate based on the height of the vertices. Because that's annoying. That's annoying. I just need to directly use it. Yeah, we'll just have a rotation. Genius. We'll see how smart this is. We'll see how good it is. We may find out it's dumb and we need to remove it. But let's see, chat. Let's see what's the situation. Okay, this will be the flow direction will be just a rotation, integer rotation. So we need to do a simple change in the lava flow direction. Here will be an integer. By default it's 0. By default it's 0. But we need to change the property. Flow direction. It should inherit an integer. Int property. It needs to inherit the int property. Like this. Flow direction. Like this, chat. Like this. Let's run it to see if it compiles. Let's see if it compiles. Type must be number. Where is this problem coming from? From JSON. Let's do call stack. Where is this coming from? Here, add property flow direction. Add property flow direction. Maybe when we parse it. Flow direction is an integer now. Yeah, it's an integer. Oh yeah, with the water. We need to change the water because it's getting here a string. Needs to be for the water an integer as well. Let's see if it compiles. Okay, it compiles. Perfect. Okay, chat. Okay. So what now? Flow direction. What now, chat? Let's go back. Let me open the window. Oh, let's go back. So for the block, where is the block? Here, block. Let me think about it, chat. We need to go to the water, to the lava block, and when we create it, I want to save a flow direction. So here to take in a flow direction as an integer. Here, int flow direction. We could calculate it dynamically. Here. To get a rotation to get an angle between by default towards the south and the current direction. If it's both of them towards the south, it will be 0. So here, let's do float angle equals an angle. We need an angle. We could do the same thing we did for the rain. For the rain, chat helped me for the rain when we added rain. For the rain, we used 8 tan for the rotation, I think. 8 tan. Look at angle. Yeah, here I've used before dot product. I don't care about that. Here, 8 tan 2f. An angle. Yeah, here we have. Oh, this was just from 2 positions. I want not from positions, but from directions, from angles. Betsy is ignoring us sometimes. That's not true. Here he is asking, why don't I make generic fluid logic? And I'm not answering because I've already answered it before, but it was earlier, I guess. Let me think about it. Currently, I want to calculate a flow direction as an angle based on a difference between 2 directions. Difference between the direction towards the south and the new direction. So how to calculate that, chat? Let's have somewhere here in the application. Here, Raylib and Raymap. Here in the application, when we start the application, here we'll immediately close it. Running equals false. Let's run it. Here we will test out. What's the issue here? This part. Here, let's run it. We will test out at the beginning, trying to see if we can calculate the angle. Here it will be a lot faster if we do it. We'll try to do it here. So what will be the logic here? Let's here have two vectors. Vector, and let's maybe even to simplify it even more, just in the 2 dimensions. Maybe just in the 2 dimensions. Is it only in the 2 dimensions? Because chat, what do we do when we need to go down? I haven't thought about that. If we want to go downward, I haven't thought about that. Because if we use for the flow direction an angle, if we use an angle for the flow direction, we only cover on the X and Z. What if the water needs to go down? It shouldn't be a problem, because if it's going down, we're not seeing the top and bottom. We're not seeing the top and bottom, so it's not an issue. It's not an issue. Let's test out with just a vector 2. Default is towards the south. The default is towards the south. Vector 1. The vector 1 is towards the south, so the X is 0, and Z is positive 1, I think. Was the south towards the positive direction? Let's see. Q mesh template here. The south is positive Z, yes. South is positive Z. And then the other vector will be, let's say it's towards the north, so -1. Let's say it's -1. And here, let's calculate an angle. Let's calculate an angle from the 2 directions. Let's calculate an angle. What are we going to use for this, chat? Should we use a dot product? Oh, the 1 hour is over, chat. 1 hour is over. Since the 1 hour is over, let me bring back the previous progress. Like this. Let me bring back the previous progress. Okay, chat. How much time do we have left? We have 1 hour and 15 minutes. So where's chat? I'll create a poll. Here. Start a poll. Should I switch to another feature? Yes, no. Should we continue the lava, or should we switch to another feature? Currently, this is because 1 hour is over. 1 hour is over. We managed to implement this. Currently, we're focusing. If you give me more time on lava, I'll continue the flow direction. Because look at here. Here it flows towards the south and towards the north. And towards the north it flows perfectly. Here we need to make it still. And here towards the west and the east we need to make it properly flowing. We'll do that with the flow direction using an angle. We'll do that, and then we'll make it continue to spread. We'll make the lava continue to spread even more, just so we can actually finish it to be like the water, but with a proper mesh. With a proper mesh, chat. Just continue doing the lava. It's not just continue. It's important to hear what chat is thinking, because look at how it's pretty close, chat. It was almost 50-50. Okay, now it's mostly no. Now it's mostly no. I haven't voted. Okay, chat. Okay. It's mostly no. So we continue with the lava. Yeah, should I switch to a different feature? Everybody is saying no. 70%. Okay, so we continue with lava. We continue, chat. Okay, I was just checking. Okay, so we will do another 1 hour timer. Chat, we're doing another 1 hour timer. We're doing another 1 hour timer. Let's do this, chat. Let's do this, chat. To interpolate the animations, we could we could interpolate between them. Interpolation would make it smoother. Next cleanup stream when? We'll think about that. We'll think about that. Okay, so chat. Let's do the flow direction, chat. Let's do the flow direction. To do the flow direction, what currently stopping us is math. Basically, math is stopping us from continuing. To make it simpler, I'm doing here, I'm running the code separately. Here, this code. I'm doing a very simple example, just so we can iterate faster until we reach a solution. We have two directions, towards the south and towards the north. And so the result, I need an angle between the two vectors, which should be, in our case, it should be 180. It should be 180, chat. Excalibur here. This is the first direction. This is the other direction. This should be 180. This should be 180. This should be 180. How will I calculate this? Do we need a dot product? Do we need a dot product? Or do we need from Raymath cheat sheet? I think they had a function. They had a function angle, vector2 angle. You give it two vectors and you get an angle. Parameters need to be normalized. Should be aligned with GLM angle. Yeah, let's try this, chat. Let's try this. Vector2 angle. Let's try this. And it returns a float here. Let's do vector2 angle between V1 and V2. And we need to implement it from Raymath. And here let's do trace lock. Let's do trace lock, lock warning. Let's do here text format. We'll do text format angle. And here angle. Like that. And let's see what the result is, chat. This should be 180. How much do we get? Do we get a warning anywhere? Yeah, angle. Oh, it gives us minus 3.14. That's pi. So we need, oh, it's in radians. Let's multiply radian to degree. Radian to degree. Radian to degree. And it gives us minus 180. Perfect, chat. Minus 180. Perfect. Perfect. Minus 180. Okay, what if we give it towards the... what if the direction is towards the positive x, which should be probably the east? Let's see the result. We get minus 90. We get minus 90. We get minus 90. So what if we do minus 1 on the x, minus 1? We get positive 90. We get positive 90. Okay, is this a problem that we're getting positive and negative angles? Do we want, for the rotations, I prefer to have from 0 to 360. To not have the angles between negative 90 and 90. Between negative 180 and 180. So let's do plus 180. Let's do plus 180, plus 180. Let's do plus 180. So what do we get now? We get 270. Perfect. Perfect. And if the second direction is towards... If the second direction is towards the north, now what do we get? If it's towards the north, it should be 0. It's 0. 1 minute, chat. It's 0. Because before it was minus 180. It was minus 180. It should be 180. So we do plus 360 maybe? Plus 360. Plus 360. I want to align it just how I want it to be. So we get 180 now. We get 180. If both of them are the same, what do we get? If both of them are the same, we get 360. Bro, why do we get 360? Oh, because before it was 0 and we are adding 360. Because before it was 0. Could I make my own implementation? Oh, they're doing a dot product. Yeah, they're doing the dot product. I think the dot product was between -1 and 1. Is this an issue? Is it an issue? It shouldn't be. It shouldn't be. What if the x is positive again? What if the x is positive? We get 270. If the x is positive. If the x is negative, we get 450. If the x is negative, we get 450. Chat, so for the angles, is it an issue that they are between they have negative numbers? Is that an issue, chat? Is that an issue that we have negative numbers? That's what I'm wondering. Is it an issue that we have negative numbers? Here, this is 90, but like this should be -90. Yeah, -90 angle. Is this an issue, chat? Is this an issue? Is this an issue, chat? I like how the code is working. I don't like we have negative angles. Is this an issue? I don't know what chat is talking about. I thought angles would only work with 0 to 360. I was also expecting the angle to be between 0 and 360, but here Raylib gives me as a result between -180 and 180, which is bad for my rotations of the textures, because the rotation of the texture accepts between 0, 90, 270, and that's it. Yo, what happened? Let's open chat here. I think something happened, chat. Yeah, here. Yeah, super chat. Yeah, thank you, man. I appreciate it. I don't know why it's not showing in YouTube. Ah, okay, now it's showing in YouTube. YouTube is just bugged. I appreciate it, man. I have no idea what knock is, but thank you, man. 20 of something, how one viewer said. One viewer called it 20 of something. Chat, my bot suggested this poll. My poll suggested this poll, which is basically asking for the idea of having flow direction be an integer rotation? It's interesting looking at what chat thinks with a poll. Okay, chat. If we use negative angles, currently, how do we have the directions, chat? How do we have the directions? Currently, let's put up the axis here. I want here, this is the x, this is the x, or like, let's say this is the z, this is the x. Where is positive x? Positive x is towards positive z, positive x is the east. This is the east. This is the east. This is the south. Here is the north. This is the north. And this is the west. This is the west. Currently the default direction is the south. The default is the south. The default is the south. And I'm expecting it like this, chat. If I give it towards the east, I want how much? I want here to be 90. This to be 90. This to be 180. This to be 180. Here to be 270. 270, and here to be 360 or 0. This is what I want. This is what I want, chat. If we have this, we will have a flow direction, we'll have animations, and we'll have the second stage of the lava. We'll have, this is the only thing that we want. This is the only thing we want. So chat, most people, 50%, are liking the idea of having the flow direction be rotation, but the other half want to wait and see if it's actually a good idea. Okay, so, but what's the current situation by default? What's the current situation by default? The current situation is if we don't make any changes. If we don't make any changes, currently the south is 0 if we don't make any changes. In reality, the south is 0, which is fine. South is 0, but how much is towards the east? How much is towards the east, chat? By default, towards the east, which is positive x direction, is the positive x direction. Let's see how much it is. Positive x is minus 90. What if we change them here to be the second vector and here to be the first vector? If we swap them, what if we swap them? We get positive 90. That's good, chat. That's good. We get positive 90. Okay. I just swapped them and now we're getting better results. So now this is positive 90. So let's look for towards the north. Towards the north is how much is towards the north as an angle? 180. Perfect, chat. Perfect. So towards the north is also 180. Towards the north is 180. And how about the west? The west will be minus 90. The west will be minus 90, I'm pretty sure. The west. Yeah, the west is minus 90. That's it. That's the main difference. That's the main difference. Here it's minus 90. That's it, chat. I want it to be 270. What should I do, chat? What should I do? If I increase it by 180, it will break the other three values. If I increase it by 360, I'll get here too big of results. While we're thinking about this, let me go down. It's always so annoying to set up the camera. Minus 90 module 360. Minus 90 module 360 equals 270. South just needs to be minus 180. Let me think about it. So chat, this is what I want. I want towards the west to be an angle of 270. Currently, towards the west, we have an angle of minus 90. I have an angle of minus 90. That's my only issue, chat. That's my only issue. And here it's 0. Towards the south, it's 0. I could add 360, and here it will be 270, and it will be perfect. But these two will be broken. Here I'll have a very big number, and here it will be very big as well. How to calculate angle between directions without dot product, without a dot product. How to do it without a dot product. If we have this angle. It does it by doing minus 90. It does minus 90. We want the opposite. We want this. We want this, chat. We want the opposite. Just use module. Yeah, I'm also live on Twitch. What reason you need degrees to not be negative? You're actually right. I wanted it to not be negative because of we'll be rotating the texture with this angle, and we don't have support for minus 90, but we can easily give it Let me think about it. We can do it, chat, because if I do minus 90, I'll have to do here minus 45. I'll have to do here whatever this angle is, minus 135 maybe. I'll have to have support for them as well. Yeah, we can do it, chat. We can do it like this. We can support for minus. Use module. If I use module, wouldn't be that bad for performance. And I don't get how I would use it. I think, bro, I always read chat. It's on the second monitor. I think the idea of accepting negative rotation, it fits better. It fits better, chat. We'll just use negative rotations. We'll just use negative rotations, chat. We'll just use negative rotations. We'll just use negative. rotations. So where do we need them? When doing the lava. When we do the lava, yeah. Here, the difference. Yeah, here, and how was it before? So V1 is the south. V1 is the south, like this. Like this. Okay, chat. So we have the difference as a vector 2. We will just have here the difference x and the difference z. And we have the angle. We have the angle. This angle, let's save it in the properties. Let's save it in the properties. Here. Let's save it here. Let me think about it. Here, this is an int property. This is for the flow direction. The value will be this angle. It will be this angle. Done, chat. Like this. Done. Let's see if it compiles. I don't want to use module. Like this, chat. Minus 90 module 360 270. And I think it worked differently in C++, the module. I think it worked differently in C++. There are, I think, two major implementations for the module. There were two different implementations, and C++ was the exception, the different from the other ones. If you do module in Python and in C++, you'll get two different results. We found that the hard way when we had the annoying bug with the module. But I can try it here, minus 90 mod 360 270, and let's do online CPP. Here, and let's do float angle equals minus 90, and here let's do angle mod 360, and let's see what the result is. Oh, was it only for integers, the mod? Was it only for integers? Yeah, I think it's only for integers. I think it was only for integers. Yeah, yeah, look at this, chat. Minus 90. You see that, chat? You see that? Minus 90. But if I do 460, it's 100. You see that, chat? When it's minus 90 in C++ is different. And we did a custom function to fix this problem. If we do it in Python, it's proper, chat. In Python, it should run properly. Online Python. In Python is different. Here, if we do Python mod module operator, yeah, like this. So here, if we print, bro, what's this print, man? Print how much? Minus 90 mod 360. Run 270. You see that, chat? In Python is 270. When we use module 360. In C++, it's minus 90. To fix this, we implemented a custom module, but I don't want that. I don't want that. It's fine. We can use negative. You can add 360 before module. Plus 360. Yeah, we could. We could. But no, that's a mistake. Maybe. Let's see if we do 90. 90. Oh, wait a minute. 90 is perfect. 180. It's perfect. Okay, chat, should we use module? If we do 0. It's perfect. It's perfect. Yeah, we can do this, chat. Okay, we can do this. We can do plus 360 module 360. Okay, we can do this, chat. For the angle, here the angle, I want it as an integer, and here angle equals angle plus 360 module 360. Okay, now it's a positive number. Now it's a positive number. You can add 360 before module. Thank you. And I'll put you in the W board. Put you in the W board. Let's move all of this. Thank you. It was very helpful. So what now, chat? Now we have the flow direction. We have the flow direction. We have the flow direction as an angle. And we run it. Okay, chat. Nice. And it's working. Okay. So we have it. Let's actually use it when we generate the mesh. This flow direction, let's use it when we generate the mesh. So generate mesh here, generate. And here for the rotation. For the rotation, let me think about it. Where do we do the rotation? What's this? No, not here. This, here. So here we want we need to give the flow direction as an argument. We need to give it as an argument. That's a bit of a bummer. Here, we need to give it as an argument. Like this. Here, flow direction. We need to give it as an argument. Like this. Value. In this function, let's accept it here. Int flow direction. Flow direction. And we'll give it here. Flow direction. We'll give the flow direction here. We'll accept it here as well. We'll accept it here. And for the water as well, we'll just give it 0. We don't care about the water. We'll just give it 0. And let's actually use it. Let's actually use it, this flow direction. We'll use it here directly. We will not need to do calculations. We'll just use it here, flow direction. Like that, chat. Let's see the result. Let's see the result. Let's see the result, chat. Let's place some lava. What do we get? Yo, no. What did we get? Oh, wait a minute. This is the west is perfect. West is perfect. East is perfect before they were broken. East and west were broken. South is inverted and north is inverted. Why are north and south inverted? Why are they inverted? Why are they like this, chat? We have support for rotations of 0, 90. Let me look at the here Excalibur. Where is Excalibur? Here. For the textures, we have support. We have support of 0 rotation. We have of 90, 180, and 270. We have the support for them. For some reason, towards the south, it's flipped. And towards the north, it's flipped. For some reason. Why is it flipped? Or maybe the way we rotate them. Maybe the way we do the rotations. South should be 0, chat. Towards the south, it should be 0. It should be 0. It should be 0. Should be 0. Yeah, this is placing lava. How do we calculate them? Yeah, this is towards the south. And here we get the difference. This is the flow direction. What's this difference? This difference is between the parent and the child, their positions. So if we place a child towards the south, the direction will be towards the south. And here we will get an angle of 0 plus 360 modulo 360. It will be 0 yet again. It will be 0. Maybe the way we are converting it to an integer. I'm not sure what coordinate system you're using, but in Minecraft, the x-axis, when viewed from top, goes up to the left, not to the right. So east-west will be flipped on your graph. Yeah, but here, chat, here, if I look at here towards the east, look at how here it says facing the east towards the positive x. The east is the positive x, chat. And it's not a problem currently. It's not. This is not my problem. This is not my problem currently. Currently, this is not my problem. To look down on the cursor and plus X is left, not right. What do you mean plus X is to the left? Don't tell me it's actually like that. Where is this negative X? This is positive X. Yeah, look at this, chat. This is the cursor. Chat, positive. Bro, stop rage baiting, man. This is, look at the cursor. Positive X. Towards here, right? Okay, let's not do this, chat. Let's not do this. Your cursor shows the axis. Red is X. Yeah. Okay, chat. We don't care about this, chat. We don't care about this. We're doing the flow direction. The angles are calculating properly. I can be sure of that. We tested all of the directions. We tested all of the directions just to be sure of the angles. We tested all of the directions that here is 0, 90, 180, 270. Like, and The problem, I'm not having that problem, chat. The problem I'm having is towards the south, when the angle is 0, is doing a rotation. It shouldn't be doing a rotation. Swap X and Y to correct show coordinate. I don't have a Y direction. Why towards the south does it rotate? Why does it rotate towards the south? Towards the south, it should have no rotations. Yeah, look at this, chat. By default, look at the top block. By default, the top block is towards the south. It should be towards the south. Let me look at the default block state of lava. Yeah, the flow direction by default is 0. By default, the flow direction is 0. And so here, this is an angle of 0. So here the angle is 180. For some reason, here we get an angle of 180. For some reason. Oh, it's the opposite direction. It's towards the source. It's the opposite direction. The flow direction. We need... Oh, let's see. Okay. It's the opposite direction. It's the opposite direction. When we calculate here, the difference. We point toward the origin. We point toward the origin. Bro, why did I listen to chat? Why did I listen to chat and lose so much time? Okay, so the east and west, we need to invert them. We need to invert the east and west. Okay, so now north is perfect. North is perfect. South is perfect. The south is perfect. The west and the east, we need to rotate them differently. We need to rotate them differently, chat. The issue is probably of the... it's probably... we need to probably change the order of rotation. Probably need to change the order of rotation. When I give it an angle, to rotate it differently, in the opposite direction. So in the template, when we do rotate, where do we rotate? Rotate texture. Here, yeah, 90 and 270. Let's flip them, chat. Let's flip. Let's flip them. And now it should be perfect. Now it should be perfect in terms of the flow direction. And this is it, chat. Okay, now they're flowing downwards. That's perfect. And we even have support for diagonal flow direction if we do the angle to be 45. But here I want this lava to be still. I want here the lava to be still. Here I want this to be still when we don't have a flow direction. Once we have the flow texture correct, we're going to give the source block separate animation texture. That's less. Yeah, it's called lava still. Direction top and bottom. This texture will just make it to be still, to not move. We'll just make it to be still. How should we do that? How can we dynamically change the texture? We just need to change texture coordinates. We just need to change the texture coordinates. Yeah, we just need to change the texture coordinates. We can just change the mesh itself. Here, lava block. Here, this block. We'll copy it. Where is it? In models. Models. Here, we'll paste it. Lava block. Here, this thing. This we need to rename it lava block steel. Lava block steel. Here this will be steel. Probably. Lava block steel. Is it 2 L's? Chat? Is it 2 L's? Steel? Steel? Is it 2 L's? Okay, it's 2 L's. It's 2 L's. Steel. Lava steel texture. We'll just change to use a different mesh, chat. We'll just change it to use a different mesh. And what else? What else? We need to actually use it. So when we render the lava, here, let's change the mesh. Yeah, let's change it here. If northeast height equals northwest height and northwest height equals southwest height and southwest height equals southeast height. If all of them are equal, this means we want it to be still. We want them to be still. Else it's flowing. Here we'll have it be still. It will be still. Let's see the result. Look at this, chat. It's still. Oh, it's better. Now it's better. Look at here. It's still lava, and here is flowing. Chat. Yo, that's cool, chat. That's cool. Yo, I like this, man. Let's change the thumbnail just in case. Change the thumbnail. Change to the newest one. Open, save. Not that big of a difference from the previous one, but still something. Okay, so what now, chat? Now we have a flow direction. And the flow direction is visualized in the animation itself. This is a huge update from the water, man. It's a huge update from the water. Look at how the water, this is the previous water. And this is the current fluid. The current fluid looks much better. But it doesn't spread fully. So what now, chat? What now? I remove the shading on lava. We could remove it. But let me think about it, chat. To remove it, I was thinking what I need to do. I will need to change the mesh itself, because for the shading, this is ambient occlusion. And I just check if it's a full block like this. This fluid inherits the full block. It inherits the full block, and depending on the height level of the corners, we modify the full block. We just lower the vertices up and down. That's why the game just checks the mesh because it inherits from a full block. That's why it automatically gives it the ambient occlusion. It's fine. It's not a priority. A priority would be now to have it spread once again. To have it spread once again, just like in Minecraft. Just like in Minecraft, to spread once again. Here. We have this chat. We have this one-to-one like Minecraft. Let's do this chat. The reason we temporarily switch to this, to the flow direction, is because I think it will help us. I think it will help us with this now, because it will be much easier to do the diagonals. Bro, I don't know if you chat hear it. We have a visitor. I don't know if you hear it, guys. But let's not get distracted. Let's not get distracted. No, don't. You heard nothing, chat. You heard nothing. No, there's nobody there. There's nobody there. I didn't. Yeah, that's right. You didn't hear. That's correct. You didn't hear. Chat, if we invite her, she will just jump around and go to the bed like last time she went on my pillow with her dirty paws. I cannot, chat. That's when I don't give her attention. When I give her attention, she stays with me. She doesn't go to the pillow. But during stream, I cannot, chat. I cannot. Let's focus. We'll just ignore her, chat. We'll just ignore her. We'll just ignore. Let's do the lava, chat. Let's do the lava. So for the spreading, you can notice how for the spreading, let me think about it, chat. Here, the diagonals. This is the tough boss, chat. This is the tough boss. If you didn't use Raylib for this project, maybe 5 times longer to take. Now, this is the tough part, the diagonals, chat. The diagonals. That's why I added the flow direction, because of the diagonals. I suppose it will make it easier to implement the diagonals. I suppose it will make it easier. The diagonals, we could just look at the direct neighbors. We can just look at the direct neighbors. And if... What about here? How should be the logic of the code? Here the lava is still. How should be the logic of the code, chat? I'm not sure. How should be the logic of the code? That's what he gets for ignoring her. This is why I'm currently struggling, chat. It's not because I'm ignoring Kat. That's why it's not because I'm ignoring her. It's because currently, when we spawn these ones, we just manually set them to be like this. We manually set the lava to be like this, but for this case, we no longer can do it manually. We need to automate it. We need to automate it. Shape, direction, every corner, show direction. Let me think about it, chat. How should we determine? Okay, we get this initial spawn. We get this initial spawn. Sure. But here, let's say, here it's different, chat. For the initial spawn, it was easy because the parent is the source. Oh, yeah, we can just check. If the parent is flat, we will say it's the source, maybe. We can just say it's the source when it's flat, like this. It's the source, so the flow direction will be just the difference from the source. It will be just the difference from the source. Here is different. Here is different. Here the parent is here, towards this direction. It's towards this direction, which is wrong. It's wrong if we use the parenting here. Here we need to ignore the parenting. And here as well we can ignore the parenting. We can just look at the neighbors. We can just look at the neighbors, chat. But we need to look at the neighbors after we spawn all of the blocks. After we spawn all of the blocks. Bro, chat is so funny, man. That is so funny. Chat, bro, chat, when you're not distracted, you give me genius suggestions. Chat, do not get distracted. I need you here, chat. I need a genius suggestion. Where is gaming? Where is gaming studio? Where is Jake? Where is Jake? Where is Maskeli? Clay? Where is Clay? Chat, lock in, man. Lock in. How much time do we have? We have about 15 minutes. We have about 15 minutes, chat. We probably have enough time to do an attempt. Here, look at this. It doesn't have ambient occlusion. Oh, but here, everywhere it's disabled. Everywhere is disabled. Let me remove the shader. Let me remove the shader. Oh, look. Does it have ambient occlusion? The lava? It doesn't. It just has the custom lighting of the faces, I think. Probably. Probably just the custom lighting on the directions. Probably. Yeah, it does. Look at this. It doesn't have ambient. It doesn't have ambient. But that's not the focus. That's not. I have zero idea about fluid. Oh, gaming, you were my last hope, gaming. You were my last hope. I have 15 minutes, chat, and gaming cannot help me, which is very bad. Which is very bad. How should we do this? How should we do this, chat? How should we do this? How should we do this? How should we do this? Let's do it. Let's actually simplify it. When the flow direction is 360, is the source. I just want to indicate the source in some way. Lava. Flow direction, when it's 360, I'll think of it as the source. I'll think of it as the source. I'll think of it as the source. And so let's go back to the lava. And let's actually save this. How should we call it? Lava has flow direction and animation rotated based on it. Let's go back. Let's go back here when we place the lava. So how should we do it, chat? How should we do it? Here we can just look at the only thing. Okay, chat. We can simplify by. Let me think about it. By only focusing on the layers, chat, the on-tick update probably to make the on-tick update to be like the water, the simplified water. Probably to have the on-tick update be like this, chat. The on-tick update to be like this, just to spread out the layers. And then after we have that, to update the mesh. First to spread the layer and then to set the mesh. So every block to look at the neighbors. That would be easier. But what's the issue? The problem is that if I call the update in the function, the on-tick update, if I call it there, it will be at the wrong time. Because basically we'll just be placing the block here. We'll call on update, here on update, here on update, here on update, here on update, which is wrong. Because when we do the diagonal, wait a minute. It's not a problem, actually. It's not a problem. Because the spreading of the liquids happens, in a flood fill style. So when we get this diagonal, it will already have these neighbors. We don't care about the new neighbors. We don't care about them. So it's fine. Oh, we can just do the update here. We can just do the update here. We can just do it here. Okay, chat. So when we place a lava block, we'll do an on update. So every update change the... Yeah, to have a function that just looks at the neighbors and based on the neighbors to decide the mesh. And it will have the proper layer. Is there a reason why you didn't just go with OpenGL? The reason is simple. Raylib has a lot of abstractions that speed up the process, like having a camera, like being able to draw easily like that sphere, like handling to easily draw any kind of simple shape I want, to easily draw here this simple outline is from Raylib. I don't need to handle it. And Raylib allows me to spawn allows me to load modules. Raylib handles loading of modules. Do you know how much time it takes to load a module, man? Like Raylib, that's the reason I didn't just go with OpenGL. I've already tried that with the Java clone. You could be making a new game and upload it instead of making a clone. but I could be making a clone. It's just CPP and Raylib OpenGL. Yeah, CPP, Raylib, OpenGL, and I'm using for the noise generation, I'm using Fast Noise 2, I think was called. Fast Noise 2. And I'm using sometimes GUI for UI, debug UI. Let me think about it, chat. Okay, every time we spawn lava, we'll look at the neighbors. Every time we spawn lava. Yeah, I have, and sometimes I look at old messages. No, chat is not delayed. These are just some important old messages. Chat is not delayed. Chat is not delayed. Alex, I see your... the delay is maybe 10 seconds, chat. The delay should be 10 seconds between chat. So if I say type 1, it will take 10 seconds. So 50, 51, 2, 54, 56. Okay, it was around 6 seconds. Let's say 8 seconds. Around between 6, 8, it was 8-second delay. Let's say. It was 8-second delay. Sometimes it's 10 seconds. Okay, chat. Let me think about. We have 9 minutes. We have 9 minutes. You deserve a mute. We have 9 minutes, chat. How should we implement this? Okay, let's have for the lava. Let's have for the lava on update. On update. And here we will handle. Oh, wait a minute. Yeah, on update we will handle the. Bro, do you hear the? Do you hear someone, chat? Do you hear someone? Let's handle the height of the 4 corners in on update function. Let's handle them here. That was just the battle cry for leaving. That was just the battle cry for leaving. She left. We lost her, chat. She left us. She left us. Here let's get. Where do we have phone update? Here let's get position details. Like this. Let's implement the on update. On update here. We'll handle the height. We'll handle the height on update function. We'll handle it in this on update function. The height of the 4 corners. We'll handle them here. We'll not be doing them here. Here we'll focus just for the layers. We'll just focus on what layer it should be. What will be the current layer. Here let's just give it a layer of 4. A layer of 4, and it will handle the flow direction as well. Should it handle the flow direction? Should it handle the flow direction? No. It shouldn't. It shouldn't. It shouldn't. Okay, so we went from layer 12 to layer 4. How much is this, chat? The difference? Difference is 8. Difference is 8. But how much can lava spread, chat? How much can lava spread? How much can lava spread? It can spread 1, 2, 3 times. It can spread 3 times. So from 12, so 4 times each. Wait a second. So 12, then what's the minimum? What's the minimum? The minimum is 2, so we get 10, and we divide by how much? 1, 2, 3 by 3. So we remove 3 every time, maybe. So 12 minus 3, it will be 9, then minus 3. Bro, why do I get an AI overview for this simple calculation? Oh, that's crazy. We get 6, and then minus 9, we'll get 3. Okay, we'll remove 3 layers every time, maybe 2 layers. 4 blocks or 8 in nether. No, I'm doing for the height. I'm doing the height. Oh no, we can do, no, we can do 4. We can do 4, chat. We can subtract 4 every time. We can subtract 4 every time. Here, if layers is less than, what do we call it? Const static int layers difference equals 4. And if layers is less than layers diff, to return, to do nothing. We cannot spread further if the layers is at this much. I just wanted to then just brings up AI overview. Bro, I think she's coming back. Okay, and here we do layers minus layers difference. That's it. That's it. And in the function here, we want here the int neighbor layer. That's it. Our neighbor layers. We will not be changing the heights of the 4 corners, just the layers. And we will not be changing the flow direction. Have we placed the block? And here we need to do block state on update. We need to do on update neighbor position. We need to do on update. In the on update, that's where we will update the flow direction and the corners. That's where we will do it. That's where we're going to do it. Let's check the spreading here. Let's just check the spreading. Let's check the spreading. No. Oh, okay, it's all right. Okay. So now let's update the visuals. We will update the visuals based on the neighbors. Now let's update the visuals based on the neighbors. How should we do it? Here, on update. Here, I want all of the neighbors. We'll get them like this. On update here, I want all of the neighbors. This is the north, this is the south, this is the east, and this is the west. These are all of the neighbors. Also, I want the current properties. I want the properties as well. My current properties. I want my current properties. So what now, chat? And we're at the limit of the stream. We're at 3 hours. Let's give it some bonus time because I feel like we're close, chat. I feel like we're close. Let's give it a little bit more time because usually we stop at 3 hours, but let's give it more time because I feel like we're close. Okay. We're doing the lava, chat. We're currently doing the lava. Okay, we'll do a quick summary. We have a command to summarize. Summary. We have a command, but I'll also show you guys. I will also show you. So we're currently implementing the lava. We have the water. We have the water from previous stream. The water from previous stream, the flow is good enough, but the mesh is not perfect. The mesh is not perfect. For the lava, we made it. We made the mesh be just like in Minecraft, but it spread only once. It was spreading only once. Here, it was spreading only once, like in the thumbnail of the stream, like this. It was spreading only once, and it was animating properly. It had a flow direction. So we set as a goal to continue the spread like this and like this, to continue the spread. In order to continue the spread, temporarily we simplified the mesh during the spread to be like this. It's fine. We'll update the mesh after we have spawned the lava. We'll look at for each block its neighbors to determine how it should look like. That's what we are currently doing. That's what we are currently doing. Petsa will never finish this clone. You're actually right, because that's obvious, because just think about how many developers are working on Minecraft and how much money is invested in Minecraft. Like so much, man, so much. And I'm a single person with a budget of $0. And sometimes donations from chat. Like that's the budget, chat. Obviously, we will never finish this. Obviously, but it's fun, man. It's a fun experience. Yeah, the budget is chat. Chat is my budget. Okay, so chat, for every block, we look at the neighbors. We look at the 4 neighbors. And what do we do once we look at the 4 neighbors? Here we look at the 4 neighbors. How do we determine how should we look like based on the 4 neighbors? How should we do it? How should we do it? Here is very simple. Here is very simple. This element will just look at its parent. It will see it's a source. The direction is simple. It goes towards here. That's it. Here, this block is simple. It looks at its parent. It has only one parent, and the flow direction is towards here. It will have the same flow direction. If it has a single parent, we'll have the same flow direction. Done. We'll have the same flow direction. If it has two parents, it's a diagonal. It's a diagonal. Here, is it enough? Is it enough if we handle one parent and two parents? Is it enough? Because this one that has 4 parents, that's different. This one has already been updated. It has already been updated. But maybe in the future, if here we spill lava and it drops here, if lava drops here, it will change the levels. It will change the levels. Oh, I haven't thought about that when lava drops. I haven't thought about that. We don't need to care about it. It's fine to just keep it simple. How should we do it? How should we do it? We have the layers. We have the layers perfectly. The layers, we have them perfectly, chat. Just like the simple water. Currently, we've set up the layers to be just like with the water, like this, chat. The layers look something like this, where they just here they just spread around like this, chat. We have the layers like this, and this is the only information we have, chat. We have our current layer, and we have the layer of the neighbors. We have the layers of the neighbors. We could... Oh, I have an idea, chat. I have an idea. But the flow, we need a flow direction as well. We need a flow direction as well. What was my idea? My idea was, what was it? When I look at the north neighbor, to set up the northeast and northwest heights based on the north neighbor and based on the difference between our layers. So basically, if the north is lava, we'll set the northeast and northwest be the but that's wrong actually. We'll set them to match the parent heights. Yeah, the parent heights. And if then we go to the south. Yeah, when we go, oh yeah, that's a good idea, chat. That's a good idea. We could, yeah, we can go through all of the directions. We can go over all of the directions. When we go to the north, we are just focusing on the northeast and northwest heights. and we'll make them be based on the neighbor if there is one. If there is one. Very simple, chat. Look at this. We're at this block. We look at the south. We look at the south neighbor. This is the south neighbor. And it's lava. Since it's lava, we'll update our own heights of these 4 vertices to be the same as the parent. This one, the neighbor. Here we don't have a neighbor. And here we don't have a neighbor. Here we don't have a neighbor. Yeah, when we no, chat. We'll set all of them by default to be the current layer. Yeah, here the current layer, let's say it's 4, and the parent is 12. The parent is 12. We'll set all of the 4 corners be of height 4, because that's the current layer. And here we'll go over all of the neighbors. And we're going here, we start from the south. Let's say we start from the south. This is the south. This is the south neighbor. We have a neighbor there, and it's of type lava. Since it's type lava, we'll check our current heights of these 2 corners, and we'll compare them with the neighbor corner levels, and we'll set them to the highest one. We'll set them to be the highest one, I think we'll think about it. And here we look at this neighbor. We look at this neighbor. There is no neighbor. We do no changes. Here, no lava neighbor. We do no changes. No lava neighbor. We do no changes. Done. Perfect. What about here? Here for the diagonal. The diagonal everywhere. Again, the algorithm is the same. Everywhere, all of the corners are the current. The height is the layers of the current block. So let's say it's 4. Let's say it's 4. We look at the neighbors. Here we have a neighbor. We have a neighbor, and we just and the height of its corners is higher than our layer. So we copy them here and here. We copy them, and here we copy them as well. We copy them. That's it. And here we have no neighbors. We leave it like this. That's it. That's the algorithm. That's the algorithm. The only issue is we don't have a flow direction. We don't have a flow direction. That's the only issue. We don't have a flow direction. Yeah, that will be the solution, chat. That will be the solution. So here, let me get the current layers. Layers. Let's get the layers. Let's set here. Let's set by default northeast to be layers. Northwest to be layers, and here south to be the layers. Perfect. And now we go over the neighbors. We'll worry about flow direction some other time. So here we look at the north neighbor. We want to get, what do we want to do, chat? How do we need to call this? How should we call this? What do I want? For the north neighbor, I want the northeast and northwest properties. And from the north neighbor, I want the southwest and southeast properties. That's what I want. Chat. And I want to just compare them. And I want to check if the... Okay, this is the logic. If north block type equals lava. If it equals lava, that's when we execute code, chat. If it's lava, the north neighbor, I want to set northeast to be equal to the maximum between two values. The maximum between northeast and the north neighbor, it's southeast. But I need the block state, chat. I need the block state. So here we do std shared pointer block state equals world get block state. We want, what do we want? The north block state, and we want the property. We want to compare it with, what? The south. We want to compare it with southeast, like that, chat. Southeast should be std max. That should be it. Yeah, that should be it, chat. And we do the same for the northwest. For the northwest, here we compare northwest, and we do here southwest. Okay, so that's basically the algorithm. Now the annoying part is I need to repeat all of this for the other neighbors. If we have from above us, I don't know what we're going to do. And below. Why am I the villain? You can do it, buddy. Thank you, but don't buddy me, man. If the south is of type lava, do here south. Oh, this needs to be block state. Yeah, this needs to be from the block state. My bad. Needs to be from the block state. Okay, so what now? This is the block state. For the south, here I want south. I want here south. And I want here south. And here this needs to be north, like that, chat, like that. And when I copy paste, there is a problem. We could there's a problem because when we copy paste, it's easy to make a mistake that I later miss. That's the only problem with copy pasting. So for the east, I want the southeast and the northeast. Okay, the northeast, here this is northeast. I want to compare it with the southeast of the neighbor. For the southeast, I want to compare it with the northeast. And the final one is the west neighbor. The west neighbor. So here we need, this should be west. This should be west. This should be west. This should be west. That should be it. Let's test it. Let's test it. Let's see the result. Chat. What will we get as a result? Will this work? Hey. Bad casting. Bad casting. Ah, for the layers. Because I'm doing in property. Ah, layers. Should be layers. I haven't updated to be the modern version. Doesn't matter. It should be. See, what do we get, chat? Yo, chat. Hey! Hey! The diagonals. The diagonals. The diagonals are wrong. The diagonals are wrong. These one are perfect, chat. When it flows like this. Here it's not perfect. Also, oh, this is good. This is good, chat. This is good. So east and west are broken. East and west are broken. Okay, this is good. This is good. East and west. Okay, this is good. East and west are broken. East neighbor. It's good because it may be some simple dumb mistake. Oh, it will be a simple, it should be a simple fix. I'm not sure how we are going to get the flow direction. Let me think about it, chat. Do we have a simple issue with the copy paste here when I was copy pasting? So we are getting the east neighbor. We check if the east neighbor is yeah, we check if the east neighbor is lava. We check if the east neighbor is lava. Okay, let's say it's lava. The east neighbor is lava. We get the block state of the east neighbor. We get the block state. And we set the value of the northeast to be the maximum value between the current value and the block state, which is the neighbor. Block state, the southeast. The southeast. Oh, wait a minute. No, wait a minute. Wait a minute. Wait a minute. Hold on. We need to... No, I did all of the directions. The directions with issues are the east and west, but hold on a minute. I need to visualize this, chat. I need to visualize this. So let me actually visualize it. Let me visualize it. So let's say this is the east. This is the east. So we are setting, this is the east. We have south and northeast. Oh, they need to match. They need to match. That's the issue. They need to match. Yeah, here needs to be north. This needs to be south. They need to match. North, south. They need to match. Yo, thank you, man. I appreciate it. I love C++. I'll hard this. And I'll give you a like. I also love C++. I appreciate it. Thank you, man. Thank you for supporting. Okay, let's see how does the lava look like now. How does the lava look like? Yo. Yeah. Eh. Eh. Excuse me. Bro, we're almost there. We're almost there, man. We're almost there. Here, it's checking for the neighbor. And the issue is it's reading its default values. It's reading its default values. The default is 16. It's not using the current values. It's not using the current values, but it's not everywhere like that. It's not everywhere like that. At some places, it's using the proper values of the neighbors. It's not everywhere like that. Or maybe it's just not updated. Maybe it's not just updated. It's not getting. Wait, this is the north and south don't have the issues. Look at how north and south are aligned. It's again the east and west, bro. It's again the east and west. It's again the east and west. Oh, for the east and west. Yeah, the east and west, man. East and west. Uh, my bot is giving me funny poll suggestions. That was very funny, man. Yeah, here for the bot. My bot is asking, will I ever finish the Minecraft clone? And chat is saying it's about the journey. So here was the issue, chat. What's the issue here? It's again with the east and west neighbors. So by default, all of them are all right. So when we're at the east, we look at the west, and there we're using too big of a value. We're using too big of a value. We're using too big of a value. The bot wants another poll. The bot created another poll. Was it a good call? We are giving bonus time. And chat is saying, yes, we're close. We're close. We're close, chat. I know we're close, but the value we're getting is it's an invalid value. Yo, what's up, man? Thank you, man. Thank you for the support. I don't know why today chat wants to give so much support, but as always, I appreciate it. All of the support I appreciate. Two Robux, bro. What do you mean, man? It's two of something. Let me think about it, chat. Let me look at it again. Let me look at it again. Let me look at it again. The first iteration was perfect. First iteration was perfect. And then it does this neighbor. This neighbor is also perfect. Here is also perfect. But we do this neighbor. This neighbor is not perfect. Why? Let me do a quick test. Let me do a quick test. For the lava, where is the lava? Lava, let's change the default to be 6. But it will not do what I want. It will not do what I want. We are getting the block state, and for some reason the block state is with invalid data. For some reason it's with invalid data. What's the actual code? What's the actual code? What's the actual code? Bro, it's almost 1 a.m. I hate it when I go overtime. Let me go to the lava. When we place the lava, how's the order of execution? How does the order of execution go? The order is we just go over all of the neighbors, and how do we place a neighbor? How do we place a neighbor? How does the bot work? Secret. Don't you have to make it northeast and northwest for east? No, northwest, I don't care about northwest. Don't check the opposite side of west and east. You don't check the opposite side of west and east. Am I? Here. So we're looking at the east neighbor. When we're looking at the east neighbor, we're looking at the northeast and southeast. We're looking at the northeast and the southeast of the east neighbor. And we're using the northeast. Wait a minute. Oh, wait. No. We're using. Wait a minute. Shouldn't we using the south? No. My brain hurts, man. My brain hurts from. Let me look at it here. No, wait, let's draw it, chat. Let's draw it. Bro, my brain hurts. Let's draw it, chat. Let's draw it. I want to visualize it. Like this. Like this. And the neighbor is like this. This is the east neighbor. This is the east neighbor. Oh. Oh my, I am the stupidest person on earth. I am the stupidest. Oh, it's the opposite. Bro, how am I so chat? Am I cooked, chat? Am I cooked? I'm like negative IQ. I'm room temperature IQ. I'm room temperature IQ. Take a break. Finally. 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 The only problem is the animation, chat. The only problem is the animation, because it flows towards the south. We don't have a flow direction. Oh, brother. But we don't have a flow direction. Should we attempt to do the animation? Oh, flow direction towards the lowest corner. I had flow direction. But it was manually calculated. It was manually calculated. Yeah, we can do the lowest corner. Yeah, the lowest corner. And the highest corner. The lowest and the highest corner. And that's the direction. And we'll do the same logic like before. We'll do the same logic as before. Can screenshot this. We can update the thumbnail. Oh no, I think somebody's coming here. I think we're going to have a visitor. Update the thumbnail. Oh no, we have a visitor. Oh no. Oh no. No. We have a visitor, chat. This is just a slight distraction, chat. This is a slight distraction. Okay, let's focus now, chat. Let's focus. Let's focus. What are we going to do with the flow direction, chat? What are we going to do with the flow direction? The idea is to take in the lowest corner and the highest corner. That's how we're going to calculate the flow direction. and we'll use it to rotate the texture with that strategy. That's what we're going to do. That's what we're going to do, chat. Okay, chat, let's actually do it. So once we calculate the corners, let's get the smallest one. No, we don't care the actual value. We don't care of the actual value. We want to know which one it is. We want to know which one it is. We want to know which one it is. And we can do a vector 2. We can do a vector 2 to save which one it is, the lowest one. Let me think about it. No, I have an idea. We can number them 0, 1, 2, and 3. We can number them as IDs. We'll have two arrays. We'll sort both of them at the same time. We can have a vector as well of nodes or just two arrays. We'll sort both of them, and the first element will have both the value and the ID. And the last element will be the highest corner. It will be both the ID and we'll do that, chat. We'll do that. That's what we're going to do. That will be the fastest solution. That will be the fastest solution. That will be the fastest. Kat is just enjoying herself. She's having the time of her life with the belly rubs. She's having the time of her life. I cannot use my other hand, chat. If I stop doing belly rubs, she'll go on my pillow. That's why I'm not continuing. I'm stunned, man. I'm stunned. Okay, I'll do it, chat. I'll do it. If she starts leaving, I'll have to remove her. Sadly, I don't want her to go on the pillow. Code with one hand. I cannot, chat. I need the mouse as well. Okay, chat. Let's think about this. Let's think about this hostage situation. Send help, chat. Send help. I need a second programmer. I'll create two arrays, chat. I'll create two arrays. Let's create two arrays. Let's create two arrays. Let's create two arrays. How should we do them? Integers. Integer. Corners. Brother, I cannot type. Corners. Corner ID. It will be 4 corners. And we do, and it will be like this. It will be 0, 1, 2, 3. Then we do integer corner value, height, corner height. It will be how much? Here we do north. Let's do with the positives. Southeast, southwest, then northeast, northwest, like this. And we need to sort them. What sorting algorithm are we going to do? Sorting algorithm. Let's search for a simple one. I want login sorting algorithm. Or like C++ sort to arrays. Or like C++ sort with IDs. I want IDs. I want to know the IDs. Or we can do nodes. We can do nodes. We can do a node to have only one array. To have only one array. Let me think about it. Yeah, here we sort the array, but we don't have the values. Oh, here we have a custom sort. We have a custom sort. Yeah, we can do a custom sort with one array. Custom sort with one array. We could do custom sort with one array and a custom node. Here, custom node. We can do that. And to sort them based on the only one value. Based on one value and to have the ID, to remember the ID. To remember the ID. Let's keep it simple, chat. Let's keep it simple. Here we'll do structure node. We'll have ID. And we'll have height. Have height. And here we do std vector. Corners. We do, how did they do it? Brother, how did they do it? Equals with an equal. We'll do it like this. So here, like this. Here I want 0. This will be southeast. 1 will be southwest. 2 will be northeast. And here will be northwest. Like this. So we will do this custom sort. We'll do this custom sort. We'll do custom sort. Like this, custom sort. Here was the issue. Here for some reason it's complaining. Why is it complaining here? Why is it complaining here? Chat. Why does it complain? Yeah, stop complaining. Why is it complaining? Maybe here to do as node. This. What if I remove all of this? Okay, nice. What if I remove just this? Okay, if I have this. It seems to be working. No, sometimes chat is helpful. Sometimes chat is helpful. Bro, she's enjoying the belly rub so much. In 30 minutes, I need to go to bed, chat. In 30 minutes, I need to go to bed. Let's speedrun this, chat. Let's have the sort algorithm. Have the sort algorithm. Let's speedrun this. What do I need to import algorithm? Yeah, algorithm. I need to import algorithm. Like this, std sort. Here, this is corners. Corners. Corner. Node. Nodes. We compare based on the height, like this. Now we will have the lowest corner and the highest corner. We'll have the lowest and the highest corner. We could have instead of an ID to directly have a direction. Directly have a direction vector. And or like points, to have points. To just have points. To just have points. Yeah, like coordinates. Like coordinates, to have here vector 2 coordinates. And here this will be southeast. This is 1 1. This is -1 1. This is 1 -1. This is -1 -1. Like this. And so here, how does the sorting work? What's the first element? Is it the lowest or the highest? Is it the lowest or the highest? So here, the lowest. The first element should be the lowest. The last element is the highest. So we need a direction from the highest to the lowest. So we subtract. Okay. Yeah, we need. Where is the lava on tick update? Here. We need this difference. We need this difference. This difference is between corners, the first one, and corners, the last one. But coordinates, and I want a vector 2 difference. I want a vector 2 difference. I want a vector 2 difference. A vector 2 difference. And let's calculate the angle. Let's calculate the angle. Bro, if this works, if this works, this will be so cool. If this works. So this one is towards here. This is just the diff. It's just the diff. Here we can just do flow direction. Here we can just do flow direction. Let's test this, chat. Let's see, chat, will this run first try? Will it run first try, chat? Will it run in the first try? Will it run the first time? Okay, it compiled. Okay, let's actually run the code. Will it run the first time? It's towards the south in the flow direction. It didn't work. We're not changing it. The default is the south. Flow direction is not changing. Flow direction is not changing. Why is the flow direction not changing, chat? Yeah, flow direction is towards the south. So the angle is 0. The angle is 0 for some reason. For some reason the angle is 0. Why is it 0? Why is it 0? Why is it 0? The coordinates? Vector 2 subtract. Okay. So if it's okay, let's think about this, chat. Let's think about this. We're picking the first element, which is the lowest one, and the last element, which is the highest corner. That's how we get the flow direction. We have the coordinates of them, we just subtract them. So let's say chat that it's diagonal. Let's say it's very simple. It's from the south to the north. So let's say we do towards the north. So 1 minus 1 is 0. Minus 1 is minus 2. Normalized is minus 1. So direction is towards the north. Perfect. Yeah, should be working. Flow direction is towards the north. And here we calculate the angle and we change the... Oh, let's see if we need to update the subchunk. Probably not, but let's see. Do we need to update the subchunk? We don't need to update the subchunk. Yeah, why is the flow direction not proper? Bro, why are you talking about element of surprise? It's like this is a chat of a different stream. What's the issue here, chat? When are we calling on update? When are we calling it? Bro, I need to go to sleep. Here on update, and we set position dirty to update the subchunk. Let me think about it. We are at 4 hours, man. Different streamers chat. Chat, help me. What am I missing? On update, we calculate the new angle, and it's the proper one of the lava. Where is the lava? Here, lava on update. We calculate the angle. Maybe the sort. Yeah, we get the corner, the 0 corner, and the last corner. Need to ban somebody. Let me think about it, chat. Yeah, we sort them with this custom function using just the heights. And then we use this difference between the first corner, which is the lowest height, and the last corner, which is the highest height. We normalize it. We have two directions towards the south and the flow direction. Are we sure all things are vector? They should be. If two corners have the same height, that's not an issue. We still get the lowest and highest. To remove background, I just use OBS in a green screen with masking to remove the green color. And the angle we calculated the same way we calculated before. That's not the issue. And here we change the flow direction property. We change the flow direction here. Okay, I have an idea. Let's change it to 180. This will change the flow direction towards the north. This will change it towards the north. Let's see, what do we get? Is it towards the north now? South is towards the north. Yeah, it's towards the north. So the issue is with the angle. The issue is with the angle. That's the issue, chat. The issue is with the angle. The angle is always 0 for some reason. The angle is always 0. What should we do, chat? The problem is that this angle is 0. That's the problem. This angle is 0. The she. The angle is 0, chat. That's the issue. We figured out the issue. The angle is 0. That's the issue. Because diff is always 0, 1. Oh, okay. That's a... we're cooking. We're cooking. Thank you. We're cooking. Thank you. We're finally thinking. We're finally thinking, chat. Nice. Okay. So the difference is always 0, 1. Why? Why is the difference always 0, 1? Why is the difference always 0, 1? We subtract. Wait a minute. Are the coordinates different? Are the coordinates different if we subtract? These ones will get wait a minute. Wait a minute. Are we using the actual heights? Yeah. And here we're getting the first and the last corner. We're getting the first and the last corner. Let me think about it, chat. First and last corner. And we subtract them, the coordinates, and we normalize it. And we normalize. And vector subtract just subtracts the x and the y. Just subtracts the x and the y. Okay. I cannot rely anymore on chat. I need to figure it out myself. And we're 1 hour overtime, chat. And I need to go to bed. And chat cannot help me. Chat is thinking about Planet Crafter. My cat has left me. I don't have emotional support. I don't know, chat. I cannot log in. I have unlocked. I cannot log in. I have unlocked. Let me think about it. We have the 4 corners. We have the 4 corners. We sort them. The sorting doesn't matter. Even we would have at least gotten different angles. Maybe the sorting stays the same always. And let's say there is no sorting. So by default, we should be getting this minus this, which will be 1, 1. It will be 1, 1. It would be 1, 1, which would be an angle of 90. It would be an angle of 90, which is something else. We're so close, chat. We're so close. We have coordinates here. Let's call it here vector 2, just in case. Vector 2, just in case. And this to be node. Just in case. Yeah, it's always towards the south. Yeah, towards the south. It's always towards there. No matter the way the corners look. No matter how the corners look, it's always towards the south. It's always an angle of 0. It's always an angle of 0. Let's do a breakpoint. Let's do a breakpoint. Let's do a breakpoint. Yeah, we're overtime, chat. We're overtime. I much rather be overtime on this than at a job place I don't care about. I'd rather be overtime here, chat. Okay, we're doing a breakpoint. So the difference bro, continue. I don't get any values. I don't get any values. Yeah, we're in release, but we should be getting some values. Isn't it better to use min function? It's in the algorithms library. But we have a custom node with a height. To check corner order, we are getting the coordinates of the corner. To check the ordering, we will need to debug it, and sadly, in release mode, we cannot debug it. And if we go in debug mode, there's an assert I have been ignoring for a long time. Printf. Yeah, let's print them, maybe. The heights, if they're sorted. Let's print them. Trace log. Let's do for the same way they do it here. Same way they do it here. This is corners. And we do what do we do? And here std cout. Let's do include tile stream. Include tile stream. And line. Here I want cout. I want to see out what? Just the I want to see out the corner height like this, and space, to have space. That should be it, I think. Let's see if at least they're sorted. Let's see if they're sorted. Yeah, they are sorted. They are sorted from 0 to the highest number. From 0 to the highest number. They are sorted, chat. I don't know why we continue to have updates, but they're always sorted. check the ordering. I think you're sorting the angle to 0 after you set the angle to the correct one. Oh, wait, what do you mean to check the ordering? What do you mean to check the ordering? Yeah, this is the angle. And here I set the angle. Angle plus 360, module 360. Yeah, this is perfect. This is okay. Let's do something else, chat. Let's do something. This is good. This is good. I like the printing. I like the printing. Let's see out the angle. Let's see out the angle. Oh, bro, we are getting perfect angles. They are not perfect. They are not perfect. Oh, we are getting angles we don't support. We don't support the diagonals. Oh, and there is another issue. There is another issue. If we get like even for the proper direction, even for the proper direction when it's towards the north, towards the north, if it's towards the north, even if it's the proper direction, if it picks the diagonals, we'll still get the wrong one. Yeah. So chat was right. If two corners are the same height, it's a big problem. It's a big problem. And we need support for diagonal rotation. Okay, so this was the only thing, chat. This was the only thing. The only thing we needed to do was to print f of the angle. That's it, chat. If we have printed the angle, this would have been solved a million years ago. If we have printed the angle, it would have been solved a million years ago. Let me think about it. So how should we attempt to do this? Maybe to remove duplicates. How should we handle when they are the same, chat? How should we handle it? What's the issue, chat? How should we handle it? The issue is this. When we have the block corners like this, when it's a diagonal, like this, it's fine. Like this, it's fine. When this and this is lower, when this one is and this one are lower, but this is the lowest and this is the highest, this will be the flow direction. This is fine. The problem is when these one are the same and these one are the same, but these one are higher, these one are lower. The problem is, what if we pick again this one and this one? That's an issue. We need to pick on the same side. We need to pick on the same side. How should we handle this, chat? And the problem is, I don't know. Okay, if it's the case, or what's happening outside, man? It's too dark outside. I cannot tell what's happening. Chat, in the situation where two corners are the same height, the issue is I don't know if it's these ones or these ones, the grouping. I'm sorting them, sure. I'm sorting them. Think, Mark, think. Think. Or how should I handle this, chat? How should we handle it? Or maybe to first have support for diagonal rotations. Maybe that would be better approach as of now. To have diagonal rotations. No, it's 1 a.m. Oh, chat. We are not continuing coding at 1 a.m. We're at almost, we're going towards 5 hours. No, chat, we're not doing it. No, we have to have boundaries. Okay, chat, let's do a summary. Let's do a summary. So chat voted to implement the lava, like to fix the water mesh and to have the lava. We did the mesh, we did the spreading. The only issue was the flow of the fluid. The only issue was the flow direction. We figured out a way to do it by looking at the heights of the four corners, but we found an issue with it that we don't have the time to fix, and we left it like this. So the animation always flows towards the south. I need to fix the flow direction. And we need to have support for rotation of a texture of 45 degrees. We only support at 90, 0, 360, 270, and 180. We don't support diagonal texture rotations. Okay, chat, we're ending it, chat. Let's all go to bed. I'll at least, not the same bed. Let's go to bed if it's nighttime for you guys. If it's night, yeah, bye guys. Hopefully we have a stream tomorrow and I don't burn out. Yeah, bye chat.